Okay, so we're going to go ahead and do the video in order to cover the Gauntlet Project Milestone 1. And what's kind of cool about that is, as you can see right here, I'm currently pushing it to the GitHub. Rock on. But yeah, other than that, just be following along the project milestones that you see here. Take exists and moves in a valuable test environment, player input and player controller. Movement in a separate tank mover or pawn. Yeah, which is fine because that's input controller / mover. The player controller actually inherits from input controller, so it does that. Transform.rotate, it uses that. Character controller.simple move, yeah, it does that. Tank variables are exposed for designers in separate tank data component, yeah, it does that. Shooter component fire shell in direction tank cannon or tank is facing, it does that. Shooter component limited in fire rate using one of the timers covered in class, yes, it does that. Shells collide with other tanks, do damage to other tanks, and track which shooter fired the shell. It does that. Shells self-destruct after time and after collision with any collider. It does that. Game Manager exists as singleton and allows easy access to player tank data component and updated list of enemy tank data components. It does that for the most part. I mean, the player ship itself is actually already being generated directly from the game manager. So, yeah. Alright, so to start off, I'll just run a very quick demonstration of the function. And as you can see, there's my ship. Pew pew. Blows up. Pew pew. You can see it shifting, but that's just the way that it's working because I'm spawning bullets. Of how I'm spawning bullets. Pew 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 pew. And as you can see, if the bullets don't hit anything, they will continue on for X amount of time and then disappear. Currently, right now, the bullet lifespan is 3 seconds. But as you can see over here, the ship itself doesn't exist until the game manager actually starts up, so that's when it creates it. Pew pew pew. And as you can see, it destroys the ship after hitting it 2 times. So game manager, here's the requirements for being able to set the various variables in the inspector. So we have player health, enemy health, we have player fire rate, we have player forward speed, we have player backward speed, we have player rotate speed, we have enemy speed, we have enemy rotate speed, we have enemy fire rate, we have gravity, which I'm not really using on anything, we have the bullet speed, the actual speed of the bullet itself, and bolt duration, which is how long the bullet lasts. And then we have player ship, into which we drop ship 8. Ship 8 is not currently being shown in the object management pane over here because it's being instantiated from a prefab inside of the game manager itself, which allows me to, swap out ships. This AI master, AI controller, pretty straightforward. We have the player controller right here, and all the player controller does is it serves itself up as a recipient for the various controllers. So tank controller instead of a player controller. And for our tank controller, it accepts the input controller. And input controller is right there. Input controller actually will also decide between WASD or arrow keys, and they're set up to work both ways. Down here we have the health data, and that just pulls from tank data. Game manager, this doesn't populate initially because it's coming from a prefab, so when the ship itself starts up, it will actually fill in its own tank manager, or its own game manager, which saves a lot of heartache. But aside from that, here's the bullet prefab that it shoots. I just pulled that from there to there, and then it makes the bullet prefab. We'll go over the bullet prefab too. But Okay, so tank data. We were talking about how we would do well to manage we would do well to see that the tank data itself was being used as an axis, and as you can see here, it is being used as an axis. It's initialized with its own personal ones, but then it also does the get component just to make sure that it initializes properly when it's thrown. We have the fire bullet void, and all that really does is it creates a new instance of the bullet. And when I was talking about it bouncing the ship up, that's because when the bullet's initially created, and we'll see it when we look more closely at the bullet script itself, we will see that the bullet is not a trigger until half a second after it's created. So this prevents it from blowing up the own ship. Also we have on trigger enter dot tag equal equal bullet. What this does for me is it makes sure that it won't trigger the this ship health dot take hit unless the tag for the collider that's hitting it is a bullet. I haven't done it yet, but I could also put in one that says if other dot tag equal equal asteroid, because you saw the rocks that I have here in the window. I could also add colliders to check to see if it runs into one of these. And as you can see, I'm using the mesh collider because they're complex objects. But yeah, this is fairly straightforward. This is really just a nexus that allows my other objects to talk without it being a proper, interface. So then we come back to here, we go back to here, and we go to the tank controller script, which is also very straightforward. It just gets the input controller. That's all it does for this tank controller. Then input controller is where I have the fun. Because as you see with the input controller, it actually has a private copy of tank data, which it calls this ship data. Then it has public enums that you see in the inspector that allows you to change which controller scheme you're using. Right now, it's kind of like hard setting it to WASD in order to initiate it from the get-go, but that can be changed with the drop-down. We get down here, it picks up the additional connections for it. Gravity is not currently being used, so we aren't really concerned about that. It's just in there for a future implementation. The player fire speed is just a scaling of how long it takes to fire. The fire timer down here is almost identical to the one that we used in class, and all it does is keep track of the amount of time since it was last fired before it fires anything. Controller equals this transform dot transform direction. There's the this dot transform rotate. There's this controller not move. The only reason I went with a regular move instead of a simple move is because I wanted to be able to turn which direction my ship was pointing. So that just lets me use this controller dot move because I want to be able to change the direction of the Quanterion for the transform so that I can change the facing of the ship for turning. Still have some kinks to work out with that, but it works, and I just want it to work smoother. It was just a schema. We're just using get key, and get key is just fine for all of this, using time.delta time and rotate speed. So it's actually, so my updates are now independent of my frame rate, so I don't have to worry about it spinning around rapidly in place because it's always getting multiplied by time.delta time. So the amount of movement it makes per second should be consistent, regardless of how many frames it's currently getting. But yeah, input controller is just very straight. All it does is listen for keyboard inputs. That is very straightforward. As you can see here, there's no real logic for the pawn moving around itself. So the controller is actually separate from the pawn being tank controller itself, which we haven't actually implemented anything interesting in it yet. We're just sticking it all in input controller for the moment. But with tank controller, we just be getting updates from input controller during the updates. So over here, instead of having it an update, we'd have it in a method or a function that it just runs through the one time every time that the pawn itself is updated. But that's neither here nor there, because the two are separate and the two are currently set up. There's other things that you'd probably want to put in pawn controller that you don't necessarily need in everything else. There isn't anything in tank physics yet, because I wanted to do something along the lines of gravity control or maybe flight differentiation or stuff like that, but this has not been called for yet in the module, so it's currently empty. Tank health is very straightforward. It just keeps track of the current health of the tank that it's assigned on, in this case the starship. And all it does for tank health is, you can see right here, this tank data dot this game manager dot player health, this tank data dot this game manager dot player health. That just sends the minimum and maximum health. Although that's supposed to be max, but whatever. It doesn't make a difference because there's no pickups to heal the ship yet. So even not having the max health set yet, it doesn't actually matter in the slightest. I use integers for the tank health, so it just calculates off the basis of the bullet. So when it runs into something, you see here that it decrements this tank health, and then it checks to see if this tank health is less than or equal to 0, destroy it. We already saw that, in fact, when we shot and destroyed the enemy ship. Yeah, this is pretty straightforward. Both of them use it. The enemy ship just uses an AI controller, which has absolutely nothing in it right now. But they're identical otherwise. I mean, really, the only difference between the two is which controller they're using. Okay, then aside from that, now we have bullet physics. Yay, bullet physics. As you can see, it initially spawns with is trigger being false. And as we'll see when we go into the script here, you'll actually get to see the code behind it. And it uses rigid body. Like, I think I should point out, it uses rigid body right here in order to control the physics for the projectile. I have it not using gravity because of the fact that I don't want it using gravity, because we're in space. And I'm pretending that this is a super awesome space with no gravity. Because, yeah, super awesome space. So you can see, like, every variable for this is actually private. I get the transform for it, I get everything else for it. This just makes the bullet move. I have an onDestroy set up, so whenever the onDestroy function would be called, it goes ahead and sets it up to do something before it actually goes kaboom, and that could just be spawning an instance of like an explosion or a shock or a zap or playing some kind of sound when it hits something. One of the unique things that I do with mine is I actually use the start coroutine methods in order to initialize these when the bullet itself first begins. And like I had pointed out a little bit earlier, warhead.isTrigger equals true, warhead being the collider component. And this actually sets the trigger for the warhead being equal to 2. So because right now I'm not spawning it from a box in front of the ship, I'm actually spawning it from the origin point of the ship. If I did that, it would actually interact with the ship's collider itself, and that would be not so nice. And that would make things go smush. So yeah. But other than that, we don't have too tons of an issue. And if I wanted to do anything really special with like the origin of the bullet body, I would just have to go up in here and go bullet. And then I would just write the constructor for it. So for the constructor, I could do object owner. There's no point in doing that right now. So we have all this all set up. It just gets the instance of the game manager, gets the instance of what its bolt speed and bolt duration are. Then it starts up this start. Then it does start coroutines, and the start coroutines are one, setting a timer to enable the trigger to true, and the second one is setting a timer for the bullet itself to go kaboom. But yeah, that's very straightforward. That explains pretty much all of it. I mean, I can go and show you. Show you ship 4s, and you can just see that it has an AI controller instead of regular controller. But that's just because I haven't made a. There's no separate controller yet for it. The controller itself is outside of the controller script here. And all I have to do is set up an enumeration or a switch, and then it would just run through whatever the update loop is that applies to that given the ship's current setting. For bonus details, there was not a requirement that the rocks had to be collidable or that the barriers had to be able to destroy something other. As it is right now, you can run your ship into them without doing anything because while they are colliders, they're not being checked to see if they do damage to the ship, so theoretically you could drive straight through them. But that's not terribly much of a problem at this point since we're so early in the prototyping. The stones themselves, as you can see here, they just have rigid bodies that just have mesh renders. They have mesh filters. It's pretty simple. Use gravity as kinematic. Not much of this really matters right now. It'd be kind of interesting to make a three-dimensional asteroid game using these assets at a later point. I mean, frankly, I could do three-dimensional asteroid games with the assets that I bought for this project, between the rocks and the several versions of the ship that I have, as you can see with this one. Not that it's really super easy to see. It's kind of like a rip-off X-Wing. You could use that as the player ship, or do what some of the newer Asteroids games did and let you switch between the ships in order to choose one that best fits your playing style. But a whole lot of code for a whole lot of meh. I would like to go on the record of saying that I used the move instead of simple move, just because I wanted the direct control over the transform, and it's Quanturnion, however you pronounce it, in order to enable my ship to turn in place like it was. But aside from that, it's very straightforward. So, we've pretty much covered everything that this one needs to do. Decommense health. Yeah. When it's all said and done, a lot of this stuff is very simple and straightforward. So, that's my presentation for this. And for a final show, da-da-da, pew pew pew. And we're done.